So our next topic is titled Even or Odd Functions. Even or odd functions. Does anyone remember talking about this in Algebra 2? Yes? Okay. So there are two ways that we're going to explore even and odd functions. One of them is graphically, and then one of them is algebraically. So we'll start out with the graphically because it's a lot easier to determine even or odd when you have a graph. So graphically, does anyone remember how can you look at a graph and automatically know whether it's even or odd? If it what, I'm sorry? What do you mean bounces? So you said x to the power of 2 bounces on the x-axis. So based on crossing or bouncing, is that how you tell whether it's even or odd? It's actually for something else. But we are going to use that, but it's okay. Thank you, though. I appreciate you sharing. Anyone remember? Lindsay? Symmetry. Okay? There are two types of symmetry. Okay. There's one that says symmetric with the y-axis. Does anyone remember what that one is? You have a 50-50 shot. Take a guess. Even or odd? Even. Okay? So an example of this would be y equals x squared. Okay? The graph of y equals x squared looks like this. Do you guys see how there is symmetry along the y-axis? Cool. If there's symmetry along the y-axis, then it is considered an even function. Cool? Questions about that? All right. If there is symmetry with respect to the origin, then it is an odd function. Okay. Do we know what the origin is? So the origin is actually a point. Are you guys with me? Versus the y-axis is a line. So symmetry along a line, all you got to do is fold along the line, right? So if I folded this along y-axis, it would match, right? But if it's a point, folding isn't really the way to go. Does anyone know how to determine symmetry within a point? Say that one time. Yes, one way to do it is by rotating 180 degrees. Very good. Okay, so I'll go ahead and show you an example of what that means. So let's go with y equals x to the third power, which is our cubic function, which we learned last time looks something like that. Yes? So now, luckily, I actually have paper that I can flip upside down for you. So have a mental picture of what this looks like right now. Okay, so you have it. If I switch and I flip my paper 180 degrees, which is literally upside down, does it look exactly the same? And the answer to that would be yes, if I was actually graphing exact points. But yes, you guys with me? The left side's going down, the right side's going up. So when a graph has that type of behavior, that is said to be symmetric with respect to the origin. Cool? So it would be considered odd. Okay? Questions about symmetry with respect to the y-axis or the origin? Okay? So really quick, as a class, there were 11 functions that we covered last class. Linear, quadratic, etc. I need to know which ones are even, which ones are odd, to make sure that you all know which ones are even or odd, because I will be asking you about that on your quiz, which your first quiz is next Thursday for you guys. Yes? Did you flip it upside down? So it will be neither. Okay, so let's talk about it. Okay, so there were 11 functions. Okay, so here we go. I'm not going to redraw them because you have them or you should have them. First function, linear. Look at your graphs. Even, odd, or neither. Odd. Beautiful. Quadratic. We actually just covered that one. What is it? Even. Square root. It's neither even nor odd. Okay? Cubic. It's odd. What about the cube root? It's also odd. Very good. Okay. All right, absolute value. Even. Okay. We have exponential. Neither. Very good. What about the log function? Neither. Very good. We have the rational function. Good. It's odd. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. What am I missing? Constant. The constant's going to be even. Cool? And then the last one, that's 10, right? The last one is the greatest integer function. Even, odd, or neither. It's going to be neither. Okay, so I'll zoom out. So there's the 11 parent functions that we discussed last class. I will be asking you as well on the test and on the quiz about their symmetry, whether they're even or odd functions. Okay? Any questions thus far? Beautiful. Okay? So, that was the way to tell even or odd graphically. Now there has to be a way to do this with algebra. Okay? So, let's talk about even, odd algebraically. Bless you. So, algebraically. There's two steps. Okay? The first step is you need to find that. Okay. I understand what that means. Do you understand what that means? Yes? Can anybody tell me what it is that is asking you to do? Yes. Not the inverse, unfortunately. No, I'm sorry. Yes. What do you mean the negative? The negative of f? No, unfortunately, that's not asking me. Yes. Okay. It means to evaluate the function at negative x. You guys should be familiar with this, for example. Like, this has nothing to do with that. But if you see this, like f of 2, what is that asking you to do? To evaluate at 2, which means to put a 2. Do you guys see how it's the same thing? But instead of putting a 2, what are they asking you to put? A negative x. So what I'm asking you is, you're going to take your function and you're going to put in a negative x. Cool? Step 2 is you're going to interpret the results. Okay, and I'll tell you what that means. Interpret the results. Which means, here's what's going to happen. Let's say you put in f of negative x, and you get back the original function. Like, it looks exactly like the original. If that happens, you have an even function. Okay? Or scenario number 2. If you put in negative x and you get the negative of the original function. So in other words, if all the signs that were there originally switch, then you have something known as an odd function. If you don't get one of these results, then it's neither. Does that make sense? Okay. Questions so far? All right, let's do an example. Ready? Okay. So we're going to determine algebraically whether it's even or odd or neither. Cool? All right, so here's my function. F of x is equal to 2x to the 4th power minus 3x squared plus 1. Cool? So we have a polynomial of degree 4, and we're going to determine even or odd or neither. Okay? Step 1, what do? Okay, so I'm literally going to show the work. So I'm going to say f of negative x is equal to. So I'm going to show you 2 parentheses negative x to the 4th power minus 3 parentheses negative x to the 2nd power plus 1. Okay? Anyone lost as to what I did? you have to actually know, this is not algebra, this is called arithmetic. You have to know how to simplify and clean up operations. Okay? Here we go. What is negative x to the power of 4? Positive x to the power of 4 times 2. So this becomes 2x to the power of 4. Agreed? Okay. What is negative x to the power of 2? Positive x squared times a negative 3. Negative 3x plus 1. Okay. This is where now I interpret my results. Look at where I'm at. I started out with a 2x to the 4th minus 3x squared plus 1. I inputted a negative, and after cleaning it up, I am back to 2x to the 4th minus 3x plus 1. It looks exactly the same. Are you guys with me? So to finish up, I'm going to say the following. F of negative x equals to f of x, because that's my original, right? Therefore, so this 3 dots means therefore, I am an even function. Cool? Yes, sir. Yes, sorry, I forgot the square. Good catch. Thank you. Does it make sense, like what I'm doing here so far? Beautiful. Okay. Let's try another one. So example number 2. Let's say that g of x is equal to 3x to the power of 4 minus 2x to the power of 3 plus x minus 7. Are we good? Okay. Same instructions, so I don't have to write them again. Determine whether it's even or odd algebraically. Okay? All right. Walk me through it. What do I do? Yeah, so input a negative x. So g of negative x is equal to 3 negative x to the 4th minus 2 negative x to the 3rd plus negative x minus 7. Right? Yes, sir. Absolutely. If you know algebra, which you, again, in my opinion, you should be able to handle some of this like right away. I'm just making sure no one gets lost, right? If you can skip some steps, I can follow your math, okay? All right, cleaning this up. G of negative x, what happens to the first term? 3x to the power of 4. Cool? All right, what happens to the second term? Plus 2x to the power of 3. Do we understand why the sign switched? Beautiful. Then we have a minus x, and then we have a minus 7. All right? So I'm going to look at what I have right now versus what I originally started with. It looks like the 3x to the 4th is the same, but the negative 2 switched to a positive. The positive switched to a negative, and the negative stayed the same. So in other words, some things stayed the same, some things change. If that happens, neither. It either stays the same or everything changes. You with me? Okay, so then I'll do one where it's odd so you can see what I'm talking about. Cool? All right. Last one, let's say I do h of x is equal to 7x to the 5th plus 3x cubed minus 10x. Cool? Same exact process. H of negative x is equal to 7 negative x to the 5th power plus 3 negative x to the 3rd power minus 10 times negative x. Right? Okay. Cleaning this up. What would happen to the first term? It would become a negative 7x to the 5th. What would happen to the next term? Negative 3x to the 3rd. And what would happen to the last term? Plus 10x. Now it's time to interpret the results. Originally we had a positive, now it's a negative. Positive, now it's a negative. Negative, now it's a positive. Therefore, since everything switched, we have an odd function. Cool? Now, some students, I'm going to show you an extra step you can take if like this makes you feel better. Okay? There's an extra step you can take to really prove this. You don't have to. But what you could do is you can factor out a negative. Do you know what I mean by factoring out a negative? Okay? If I pull out a negative, then what would I be left with on the inside? 7x to the 5th plus 3x to the 3rd minus 10x. Do you guys agree? What do you notice is in the parentheses? The original. So if I go back and I replace it with the original, do you see how it matches exactly the rule the way you wrote it? So if that makes you feel better, you can do that. If you don't need to do that, just make sure that everything switches symbols. Cool? Now, I gave you polynomials. Do you know what a polynomial is? Yes. All I did was give you polynomials from this video and these examples, right? I don't have to give you polynomials. They could be square roots, it could be absolute values, etc. You're with me? But it still stays true. The symbols have to change in order to be odd, or the symbols stay the same in order to be even. Are we good? All right. Any questions about either even or odd?